Question number 15. A straight highway leads to the foot of a tower. Okay, let us straight away start making the diagram. This is a straight highway which leads to the foot of a tower. Let it be the tower. A man standing at the top of the tower, observes a car at an angle of depression of 30 degree. Okay, so let us make horizontal line here where the man is at the top of the tower, and from there he observes a car with angle of depression of 30 degree. So as this line is parallel to the horizontal road, this angle also will be 30 degree. Is that clear? It is due to the geometrical property. There are two parallel lines which is cut by one intersecting lines. So in that case, these two angles has to be the same. Okay, so let us come back to our question. A man standing at the top of the tower observes a car at an angle of depression of 30 degree which is approaching the foot of the tower. Okay, now what is happening? The car is actually not stopped, it is running. For example, towards the foot of the tower. This is what? This is foot of tower, and this is top of tower. So the car, and here is the car initial position. So it is approaching the foot of the tower with a uniform speed. Okay, let its speed be v. Six seconds later, the angle of depression of the car is found to be 60 degree. Okay, and how much time it takes for the car to reach from this point to this point? It takes 6 seconds. And now when car reaches this point, they see that the angle of depression experienced by this person standing at top is 60 degree. So this angle is 60 degree. So this angle also will be 60 degree. Now find the time taken by the car to reach the foot of the tower from this point. From which point? From this point. So basically what we will do now, again we will just put some names of the vertices A, B, C, D. So basically now the question is that how much time, let it be T1, it will take for the car to reach the foot of the tower. So it takes from point B to C, it takes 6 seconds. So how much it will take for the car to go from point C to D? And we have assumed that it will take T1 second. So this is the question. You can stop the video and try to solve it by yourself. And now let me just show you the solution, or let us just think together. Okay, it's given that the car is approaching the foot of the tower with a uniform speed. That is also given. So if the speed of the car in, maybe let v be the speed of the car in meter per second, then distance traveled by car in 6 seconds will be 6 into v, and then with the same speed up to foot of the tower, the distance will be v multiplied by t1, isn't it? No issues, no problem. Okay, let us just go further. Now we can see that there are again two triangles. Let us just study this diagram. There are basically there are two towers, two triangles. One triangle is this one, another is this one. So we can try to establish some um, equations with the help of these two triangles. First of all, let us consider triangle ACD, and let us also assume that AD is equal to let us say h meter, and that is height of the tower, this one. So let that be h. So in triangle ACD, we know that the angle is 60 degree, this angle is 60 degree, this is a kind of base angle, and then this is what we actually need to find, and this is actually the distance the car would travel from point C till point D. So in a way, this distance formula or unknown we can use, and h is anyway common in these two triangles, so that also we can use. So how much will be tan 60? It will be the ratio of perpendicular divided by base, because it is p by b, isn't it? Tan theta is equal to p by b. And then in triangle ABD, tan 30 degree will be equal to how much? Perpendicular divided by base, isn't it? So again, perpendicular is nothing but height of the tower divided by the base will be longer now. The base will be 6 multiplied by v plus v multiplied by t1, isn't it? So now we have got two equations, and then we need to find how much time it will take for the car to go from C to D. This is what is the question. First, and then we are not at all interested in knowing this h, means h we can just get rid of. So we have two equations and actually maybe three unknowns, but we can very easily get rid of h from here. So h will be equal to tan 60 degree multiplied by v into t1, isn't it? So tan 60 degrees root 3 multiplied by v multiplied by t1. And from here h will be equal to tan 30 degree, which is 1 divided by root 3 multiplied by 6v plus vt1. Is that correct? So what we have found, that we have found two expressions for h which we can equate basically. So we have found that root 3 times v times t1 is equal to 1 upon root 3 6v plus vt1. What is this one? This is distance, isn't it? This is the overall distance. This is the distance. So hope you will not confuse. Now there are two things. Again, still we have two variables, because we started with two equations, this one and this one, but with three variables, and then we got rid of one of the variable, but still two variables are left. So what we can do now, we can very well see that on both sides v is also common, isn't it? 6 plus t1. V is also common, and we can very easily cut this v because it is not 0. Something, the speed is something of the car, otherwise it cannot change its location, isn't it? So just let us go forward. We can also write it, just multiply both of the sides by root 3 in LHS as well as RHS. Then we will get 3t1 is equal to, this also is 6 plus t1, or 3t1 minus t1 is equal to 6, or 2t1 is equal to 6, or t1 is equal to 3 seconds. So it will take, and that will be our answer. So it will take 3 seconds for the car to further go till bottom of the tower from the point C. So this is the, now let us try some questions which are of a little bit advanced standard. So in the same exercise we will just continue with the questions which I think is a little bit complicated. Okay, the first question is the angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 6 meter from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6 meter. Okay, so let us just try to make the diagram for that. I will again read the question. The angles of elevation of the top of a tower. Let us make a tower first. Let this be a tower. And then it is talking about from 2 points at a distance of 4 meter and 9 meter from the base of the tower. Okay, so from this is the base of the tower. One point it is talking about is 4 meter, and another point it is talking about, this is 4 meter, another point is 9 meter from the base of the tower, from this point. And in the same straight line with it are complementary. Okay, what does that mean? The angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base, from here and here, and in the same straight line. So it is not that something is here or here. Those 2 points are on the same straight line. And they are complementary to each other. So let us make the elevation. This is one angle of elevation. And this is another angle of elevation. So what it is telling that these two angles of elevation are complementary to each other. So first of all, I will just name the points A, B, C, D. Let this angle be theta. Then what will be this angle? 90 minus theta, isn't it? Why? Because by definition, there are two things. Complementary. When any two angles added together is 90 degree, then those two angles are complementary with each other. So for example, angle A and angle B are complementary because when added together, they are equal to 90 degree. So that is the definition of complementary. So it is telling that the two angle of elevations are complementary to each other. So theta plus 90 minus theta is equal to 90. Isn't it? Looks true. So we can safely say that if this angle is theta, then this angle has to be 90 minus theta. Okay, now what we have to find, we have to prove that the height of the tower is 6 meter. So this completes our question. Height of the tower, which happen to be AB, we need to prove that it is 6 meter. So how we will do that? Do you have any idea? Maybe you can just stop here and try by yourself. But let me continue here to show you what should be the approach to solve this problem. So basically here, looking at the whole figure, basically you see that there are basically two triangles, and in those two triangles, one is ABC, ABD, and another is AB and C. So these are the two triangles which we can um, consider so that we get some kind of useful relationships. Okay, let us see. Let us try actually. In angle ABD, BD is equal to 4 meter, the distance from bottom of the tower, and then AB is height of the tower. And if theta is our base angle, then we can write that tan theta is equal to P by B, and here the P is height of the tower AB divided by BD is base 4. So in that way we have got one equation, tan theta is equal to AB upon 4, that we will actually use later, but now let us have a look on angle AB, triangle ABC. So here is triangle ABC, and we will try to do the same thing as we have done here. In triangle ABC, BC is 9 meter, isn't it? And then AB is common. AB is again the height of the tower. So can we write down tan theta, which happened to be 90 minus theta in this case, tan base angle is equal to P by B, where P or perpendicular is nothing but height of the tower divided by B. And here in case of B means base. What is the base? Base is 9 meter. Base is 9 meter BC, and height is anyway AB. So tan 90 minus theta is equal to AB upon 9. And then basically if you just um, if you remember the relationships, tan 90 minus theta is equal to cot theta, and this cot theta is equal to AB divided by M. Okay, how I wrote this tan 90 minus theta is equal to cot theta, that you can see in my earlier videos. And this cot theta is equal to basically inverse, it is inverse of tan theta. So 1 divided by tan theta is equal to AB by 9. Or we can write reversing both sides, tan theta will be 9 is equal 9 divided by AB. So this will act as our second equation. So this was in our first equation, this is the second equation. So here we got tan theta is equal to AB by 4, and here we got tan theta is equal to 9 by AB. So what does that mean? It means that AB by 4 is equal to 9 by AB. Let us try to write that. From equation 1 and 2, AB by 4 is equal to 9 by AB. Now do the cross multiplications. AB square will be equal to 4 into 9. And what does that mean? Then AB will be equal to square root of 4 into 9, and that will be equal to square root of 36, and that will be 6 meter. And AB is the height of the tower. So we have in a way proven that height of the tower is 6 meter.